So where we left off yesterday, we were kind of working through lesson 1.0 and lesson 1.1. We talked a little bit about Android and we started to kind of build our first app with it. So we were working on that login screen yesterday. Where we kind of left off yesterday is we had kind of mocked out the layout already, gone through how to start to use that designer and work with constraint layout. But what we needed to do next was to start hook up event handlers and make things happen when you interact with the interface. And so specifically where I want to go with that is make it do something when you click on that login button, right? So that's kind of the goal for today. We'll walk through that process, and then from there, we'll walk through that process of hooking up event handlers, and then from there, we'll get you started on lab for lesson 1.1. Okay, so that's kind of the gist of it for today on Wednesday. Tomorrow we'll look at lesson 1.2. Which will kind of continue this path. Okay. So first things first, before we get back into coding, I do want to talk a little bit about the theory of this. Okay, and specifically talking about how to handle events with Java. This is available. You can get the link to the Google Doc either from the main page, or you can get to this on Bruzel. I posted it up to both places. So. Okay, so kind of what I want to talk about here is get you to the point where you can do a few things. We want to talk about, we want you to be able to declare interfaces. We want you to be able to work with interface inheritance and kind of understand where that fits in. We want you to be able to implement interfaces using nested classes, anonymous classes, as well as Lambda functions, and then use those methods, that terminology, in order to implement and handle events in a variety of different ways, right? So I'm actually going to show you, I think, 5 different ways to handle a click event in Java, because there actually are that many right now. And we can talk about the pros and cons of each of those methods, right? But there are actually 5 different ways to handle an event today in Java, which is where things get really, really interesting. Okay, so on a broad overview, you guys are kind of familiar with events already. Events are produced anytime a user interacts with the user interface. That's the same for any sort of front-end development you're doing, whether it be with React, whether it be with JavaScript and HTML, jQuery, etc. If you're doing with those Windows Forms, you always have this idea of events, right? Now, common events that we see in the mobile world involve things like single taps, right? We will call it clicks, but really, generally speaking, the user's not clicking a mouse, they're actually tapping the screen, right? So what we see and talk about as a click is more commonly kind of called a tap. Okay, so a single tap, you might have a long press where the user holds their finger down for 3 to 5 seconds, and that initiates some sort of other functionality. It's worth mentioning that those kind of things are helpful, but recognize that most users won't know that to long press your button to make it do things. So anytime you have long press functionality, you have to be very clear and tell users that they have to do that and make that visible within the app as well. Like, those instructions have to be clearly explained, and usually explained more than once. Also, we find things like drags and swipes and stretches and pinches, key presses, etc. if you actually have the soft keyboard up. So there's a lot of different events that can happen, and some of those are very different from what you might be used to from a mouse and keyboard operation, right? A lot of these are very mobile and touchscreen focused. Okay. So in order to register a handler for these events, we have to register what's called a listener object. Okay, we've got to create and provide a listener object which is going to respond to that event. Okay, that's the terminology that Java uses. It's a little bit different from other technologies, like when we did things with, largely when you're doing things with JavaScript, you just provide a function. Say, call this function when the user clicks this button, right? And it stops at that. It's as simple as that. It's just a function. Kind of the magic of JavaScript is that every function is already an object, so we are technically still, even in JavaScript world, we're passing an object, but we largely don't care about that nuance. Largely in JavaScript, we can just think of it as a function and less so as an object. Java's the reverse. You primarily think of it as an object, and only kind of secondarily it's like, oh, it's kind of like a function, but not really, right? So because Java doesn't really have this idea of a function, you can't really pass functions around. They don't have that ability. So every function that you have, or every method you have, has to be attached to a class, has to be attached to an object. There's no array around that, okay? Which means that things get interesting, right? Because we have to inherently pass an object instead of a function where we'd like to pass a function, okay? So that's gotcha. Another thing to be wary of is that Java is a strictly typed language. Both C and C# and Java are strictly typed. JavaScript is not. So we were able to very loosely kind of, hey, I want to just listen for the click event or whatever event. I don't really care about the data types. It'll just kind of work, right? It's just kind of loose. But when we were doing this in Java, we really, really care about the types. The types have to be known at compile time, which is why we have to do all this extra rigmarole that we're going to talk about with interfaces, right? That provide a way to make this strictly typed, rather than it being loose and like, well, we don't really know what it is. It's an object. It's the event object. I don't really know what properties that has. I don't know what kind of event it is. We specify those things very, very concretely when we're working with Java. Cool. So that just means there's some additional overhead that you have to understand and have to work around when you're handling events, because of the strictly typed nature and because it doesn't really have functions. Okay. So these listener objects that we create are going to implement what we call an interface. Okay, so they'll implement the appropriate interface for the kind of event that we're going to respond to. So if you want to respond to a click, well, it needs to implement like the OnClick Listener. If you want to respond to a long press, then it's like implement the onLongPress handler. If you want to respond to keys, then it's the OnKey Listener. So you'll see all of these kind of end in that word listener, but they're all interfaces. Okay, so let's talk about what an interface is, because it's probably been a good amount of time since you've seen one. You may have encountered them in your C# class, you may have not. I don't remember that textbook going very deep in them, right? One of the things that I mentioned earlier, maybe a week or so ago, is that in the world of Java, your classes can only inherit from one class, but they can inherit from as many interfaces as you want to. Okay, so your classes can inherit or implement any number of interfaces. Okay, that's kind of inherent in their functionality. Now, broad definition of what is an interface. Okay, here's the definition that I kind of run into, and we'll kind of explain this and elaborate it. I say an interface is a formal definition of the capabilities that an object must provide to satisfy a particular contract in a type-safe way. Okay. Now, the important word in there is contract. Okay. What is a contract?
Basically like a set of terms and requirements agreed upon.
Right. So there's an agreement that there's two parties, and there's an agreement between those two parties. That part's really important. What else? There's also terms in that agreement, right? So what we put in the definition of our interface is kind of those terms, right? What are the things that we want out of that agreement, right? What are we agreeing on? Okay, but there's also a why, right? Why do we need to come to an agreement, right? All of that is kind of formalized in this idea of an interface, right? The reason that we need to formalize this is that two sides can talk to each other. The reason we're formalizing this as an interface is so two objects can interface with each other. Okay, interface, talk to each other, that's kind of another word for the same thing. So, oftentimes this comes in anytime we want to maybe extend code that exists already, right? So let's say, hey, there's already something that somebody else has written, and they've opened this little point, this little spot, where we can add in our own code, right? That ability to add our own code, whether it be through a plugin or a module system or whatever it is, typically in Java, that happens through interfaces. Okay, it actually is the same thing with C# and C++. These largely happen through an interface. Okay. So another definition that you might find if you look online, and this is one from the Java Trails, which is the official Java tutorial, says that objects define their interaction with the outside world through methods that they expose, right? So they're kind of interfaces defined by their methods, their public methods, and methods define the object's interface. Yeah, what we said with the outside world. So for instance, the buttons on a television set would be maybe the interface between you and the electrical wiring in there. So you press the power button and that turns it off or on, right? You don't directly interact with the wiring inside, because that would be dangerous and maybe beyond your skill level. Plus, you don't care about all the don't want to care about all the details behind there. We just press the button, right? So we know that the power button is going to turn it off or on, but we don't necessarily know how that's implemented, right? We don't necessarily know the details behind that. We just know the part that we see. Okay. Another definition from tutorial's point is an interface is a reference type in Java. So as you've heard, there's primitive types and there are reference types. So primitive types is that narrow list, and basically everything on the primitive list, all of those can be represented as integers or numbers. All of them can be represented as numbers in some shape or form. But this here falls under the reference category. It's very similar to a class. In fact, if you remember what abstract classes are, it's very similar to an abstract class because everything inside is abstract. So it's a collection of abstract methods, and a class can be an implementation then of that abstract interface, right? So the interface is just here's a kind of a definition, here's what I would like to have, but the class is what actually makes it real, makes it concrete. Okay? So you always find these in combinations, right? You define an interface, and then you have classes that implement that interface, right? And in some way, that implementation is kind of like inheritance, so you'll see the word inheritance as well. Okay, so let's talk about how we define a very simple interface. So if we're looking at a very simple interface here, this is a simple interface called foo. You can see public interface foo. Normally we would have the word class there to define it as a class. But here we're defining an interface instead. Okay, so we define an interface called foo, and it's got a single method inside. So that single method is called bar, takes two parameters called x and y. Both of those are integers. And it returns an integer, as you can see here, right? So it's defining that anything that implements, anything that is foo, has to have a bar method. Cool. Things you might notice that there's no body, right? The fact that there's no body says that this is because this is abstract. We don't define what this method does here. Later we define what it does. Okay, so it's not defined at this point, it's defined later. Remember, this is a contract for communication. So we're just establishing, hey, there can be these things called foo, and we can communicate them using this method called var, right? So this is kind of where it starts. You might notice one thing here. I do have a public access modifier on the interface, which I would recommend, but I don't have any access modifiers on the methods, okay? We leave the method, we have to, per the Java language, you have to omit the access modifiers on an interface because they always have to be public. They can't be anything else. They always have to be public when it comes to an interface. So that means, hey, if you want to define this method and then the class wants to later implement, you can't make it private or protected. All of those are not options. They always have to stay public, okay? Fair forewarning, don't do this on classes because for classes, the default access level is not public, it's not private, it's what we call package access in Java. Java actually has 4 different levels of access. The 4 levels of access are public, private, protected, and package. Okay, package is the one you get if you don't specify. Okay, package is kind of weird. In general, I would say you want to avoid package at all costs. It's usually not a desirable thing. Okay, so this is the one exception where I will leave the access modifier off is when I'm defining a interface. Everywhere else, I'm going to say public, private, protected. Okay. Okay. So let's look at maybe a more concrete example. So if we're looking at maybe a television remote, right? This could be for any sort of audiovisual equipment in some sense. Let's say, hey, let's define public interface remote. So this is a remote. Anything that implements or implements the remote interface should have this functionality. Okay. So it should have a method called toggle power, which I can call, and that will toggle the power state. So maybe you press the power button that turns it on or off, depending on what state it currently is in. Normal for what you might find for your remote control. You could have toggle mute to toggle it between muted and unmuted. Similarly, you could have a raise volume function that says, okay, raise it by this much, or a lower that lowers it by a certain amount. So that kind of could define the interface, say, hey, if you behave like a remote, then you need to have this functionality. Now, that remote could be from a bunch of different manufacturers. It could be implemented in a bunch of different ways. It could be using infrared. It could be wired. It could be connected any way, or going over Wi-Fi. It could connect any way we choose, right? Those details are left up to the implementer of this remote. Does that make sense? So we're just defining that interface. Okay. So more concretely, what we end up running into a lot, and what this is the main listener we're going to talk about, the interface we're going to talk about today, is in Java and Android, there is an interface called the OnClick Listener. Okay, the OnClick Listener interface. That interface defines one method, void onClick, and it receives the view. Namely, the view that gets passed in is the view that you clicked on. It's the control that you clicked on. Okay? So anytime we want to handle an onClick event, we have to implement that interface, right? I don't need to write out that code that's there. OnClick listener is already defined. I don't need to redefine it. I don't want to redefine it. But that's how it's defined. Everybody clear with that? So there's a bunch of interfaces that are already built into the Android platform that we have to utilize. And this is one of them. Okay? Everybody good with that? Keep that in your mind. We'll be using that for the next few examples, is that idea of that interface. Okay, so let's talk about how we implement the interface. Okay, so to make use of it, we have to implement it. You might notice that we omitted the bodies. Kind of already mentioned that. And that kind of comes to the fact that they are abstract. Within the interface, all of those methods are abstract. They're not defined then, they're defined later. There are 4 different approaches that we can look at in terms of how do I take those interfaces and implement them? How do I turn it into something concrete? and use it to hook up an event list. Okay. So one of those approaches is we can make the class implement the interface. We can have a nested class implement the interface. We could have an anonymous class implement the interface, or we can use a Lambda function. All of those approaches are viable when we're trying to hook up listeners. Okay. They're kind of ordered from most verbose to least verbose, right? From the most code that you have to write and down to the least code that you end up having to write. So this one, number 1, ends up being a lot of code if you go that route, versus number 4 is the least amount of code. Cool? Okay. But there are some caveats with the different approaches, so I do want to make sure that you're aware of all of those because they will pop up, right? Each of those 4 different approaches pop up in different places where there are some usefulness to them depending on the situation at hand. Okay? So let's talk about these different methods. So looking at where we ended up yesterday, okay, I've taken kind of that code and kind of gone further with it. So this is what it looks like if I want to say, hey, the class implements the OnClick Listener. Okay, so looking at kind of from top to bottom, first thing you'll see is that we've got a member variable up here, private button main login button, right? So we're defining a private member variable that has a type of button, right? So it's going to hold a button or a reference to a button, and it's called main login button. I've kind of stolen the same name that I used in the design. Okay. Oftentimes, whatever controls, whatever widgets, whatever views you find out that you need from your layout that you're using in code, I would recommend going ahead and making a member variable for every single one of them, right? So if that means you have 7 widgets on screen that you're going to be using in code, go ahead and make a member variable for each one of those 7 views. As I mentioned, I think on Monday, do not put those all on one. If you have multiple buttons, don't put those all in one line. There should be one line per variable, period. Don't put multiple variables on the same line. Okay? That could make this section tall. Don't worry about it. It's fine, right? You are going to have a good number of variables as that goes on. Next up, inside of OnCreate. So remember, OnCreate gets called. The place where this gets called is as the activity is coming on screen. Before it's come on screen, Android's going through the process of creating your activity. Okay, you can kind of think of this OnCreate as almost like your constructor. Your constructor actually gets called in an earlier point of time, but because of how things work in Android, you don't want to put any code in the constructor. Repeat that. Don't put any code in the constructor. The code that we would put in the constructor, we end up putting here in OnCreate. Okay? So, when this gets called, we're going to add 2 additional lines. Okay, these are the parts that's new. So first I'm going to say, let's call FindView by ID. FindView by ID says, okay, let's go look at that layout and go find a widget, go find a view, a component that has a particular ID. Okay, so go find it by ID, give me back a reference to it. Okay, and then I'm going to take that reference it returns, save it back to main login button so I can use it for the rest of the lifetime of this activity. Okay. As far as where that ID comes from, notice that it's r.id.main login button. Okay, R is a auto-generated class. It's generated from all of the resources under your res folder. Okay, so all the stuff that you put in res, all the layouts, all the images, all the values, all the strings, the colors, etc., those all become properties on this R object. Okay, so we're going to be using this R object a lot, right? Thankfully, Android Studio goes through the process and automatically recompiles R as you're making changes. That actually, prior to Android Studio, we were using Eclipse. That was the IDE that Google recommended, and we were using. And we had a lot of problems actually with R because Eclipse frequently would not update. We'd make changes to our resources, and it would not update R to reflect the changes that we'd made. And then we couldn't build our application, and it couldn't build R because there were bugs in our code, and the bugs in our code were caused by R not building. It was a whole mess. Thankful Android Studio is really, really stable about that and has been building R pretty much reliably. It's just like, okay, you make a change, it automatically rebuilds it. Awesome. So there's a lot of magic behind that R class. Okay, that's part of what you need to understand. So now, R has a few different properties, okay? And basically what it does is it categorizes all of those different pieces you got from the resources by what kind of thing they are. So if I want to get a layout, I would do r.layout. If I want to get a drawable, it would be r.drawable. If I want to get a color, it would be r.color, right? Or if I want a string, r.string. Etc., etc., etc. So the thing after the dot, after the R, is always going to be what kind of thing I want. So I want r.id, which says I want an ID of a component that's in a layout somewhere. Okay. Now the thing to understand here, r.id, this part after here, is not specific to the layout you're on. And that's where I said all of these IDs, all the widgets have to have a unique ID that's unique throughout the entire application because all of those IDs end up on R, right? So if you have two things that end up with the same ID, you can quickly get into trouble. Okay, so you want to make sure that they're all unique. Okay, so in the layout, we defined that the ID was main login button, right? So that was what we set up in the designer yesterday. So I'm going to say, okay, I want that button, save it back here, right? So that's the part that you really have to remember. FindView ID, and then r.id, ID of widget. That part we'll be using a lot, right? That one line of how do I get an element from the XML into the Java world is where everything starts, right? That's step one. To do anything in Java is you have to have the widgets first. You have to have the components to use first. Once that's done, now that I have the button, I can actually hook up the event listener. So I can say main.login button, set OnClick Listener, that says, okay, I want to register an OnClick Listener when you click on this button, and what I'm providing it is this, okay? Well, what's this? This is whatever class that this code is inside of, okay? So what class are we inside of? We're inside main activity, right? So because we're inside of main activity, this refers to an instance of main activity. It's important that this refers to an instance, not to the class itself, okay? If you want to get the class itself, you have to go through a different route. But this is the object, okay? So basically we're registering an activity as the listener. Everybody cool with that? Registering an activity as the listener for the event, okay? Well, that only works because other things I have done, right? And let me show you what other things I have to do to make that work. So in order to make that code work in particular, I had to go up to the top of the class. You see, we already have extends activity. I need to say implements you OnClick Listener. So when you say implements, you're saying that this class implements this interface. Okay. So I do that first, right? And that in all senses, now this main activity is an OnClick Listener. If you're thinking about inheritance, it is an activity, and it's also an OnClick Listener. It's both. Does that make sense? It inherits from both. Okay, now in order to implement, that's not the end of it. So that's step one. Step one is you say it implements the interface. Step two is you actually have to implement all the methods of that interface. Okay, so I go down here and I implement the single method of the OnClick listener, which is OnClick, right? So I need a method public void OnClick takes a view, because that's what the interface says, right? The interface says it has to have exactly the signature and exactly that name. It's worth mentioning, I can't name it anything else. It has to be named OnClick. There is no flexibility, no wiggle room on it. It has to be named OnClick because the interface says it's OnClick. Everybody hear that? That's a common point of mistakes and a common point of issues, is people try to rename that function, rename that method, and now it says, hey, you don't implement the interface anymore because the method has a different name. Cool. So you'll also notice this is override, because we're basically overriding what's in the OnClick listener, which was abstract. Okay. So then inside of here, I'm saying log.i, main activity OnClick. So if I were to test this and run this, I would find that click on the button, it would write out OnClick for logs. Cool. Questions?
Can you just explain this a little bit more?
This part here? Remember, that's, as I said, that's a reference to the object that you're inside, right? The class that you're inside. So this is a reference to our instance of main activity.
So whatever main activity is.
Right. So because main activity is an OnClick listener, I can do this. I couldn't do this. This would throw an error. It wouldn't compile if I hadn't implemented OnClick listener. Does that make sense? It wouldn't work if I didn't implement OnClick listener. Is there anything ugly or problematic with this approach? Any problems that you see? What if I want to have 5 different buttons? Well, they're all going to be registered set click listener into this, so all 5 of those buttons will go to this single OnClick listener, the single OnClick function. Which means I have to have all of the code for all 5 of those buttons here. Right? So that's one issue, right? That's one issue, is it really only works as long as only one view is going to fire that. Or you want all of the views that are going to fire it kind of to behave the same way, right? If I want all 5 of those buttons to do the same thing, then I might be okay with it, right? But if what I usually want to do is have those five buttons do something completely different, right? This doesn't make it easy to do that. I'm also exposing a public method now. Anybody who has access to my activity can call OnClick. I don't want anybody to be able to call OnClick. I only want the only thing that should trigger OnClick is when you click the button, right? But that's public. I don't have any way around that, right? So I can't rename it. I can't use different functions for different buttons. You kind of see the problem, right? See the problem with developing this way. Cool. So what I'm going to show you next is how to fix some of those issues with a different approach. Okay? Everybody good with that? Okay. So the next thing we're going to look at is how do I do this with using something in Java called a nested class. Okay. In Java, you're allowed to actually put classes inside of other classes. Okay. And that comes with a lot of little bits and quirks of how that works. Nested classes, for instance, always have a reference to the class that they're inside. So if I were to put a class in here called login button listener, then that login button listener would always have a reference to the main activity object. It implicitly gets them just by being a descendant of there. Also, you can never, by the same virtue, kind of related to that, you can't ever create an instance of that nested class without first having an instance of the parent class, right? So I can't create that nested class unless I have this main activity. Okay. So let's take a look at code. I think I went the wrong way. So here's kind of what it looks like. Here's the nested class, right? So there's a login button listener that's inside of main activity. Okay. In fact, it's worth mentioning that this needs to be inside of the class. If you take this out to either a separate file or outside of this closing curly brace, the last curly brace here that ends the main activity, this will not work for what we need it to do. Okay. The fact that it's inside is actually vital. Okay. Is actually vital. Okay. Because as I said, it gets access to the main activity itself. If you take it out, it no longer has main activity. If you take it out of this class, it no longer has access to main activity, which means it can't get access to any of our member variables, etc., or any of the functions of the activity. So oftentimes we need to reference like the controls and the widgets and other things that are part of this activity. This nested class not only gets access to all of that, one of the gotchas, or one of the kind of hidden things, is actually gets access to everything that's private. So this login button listener can actually access any private members, whether it be member variables or methods. It actually gets access to all of that in a similar way to kind of how in C++ we had this idea of files. Okay. So these nested classes are really important, right? And their special behavior is really important. Is everybody clear with that? Cool. If I didn't have this, that's the key thing that makes this work. C# does have nested classes, but they don't work the same way. C# does have nested classes, but they don't inherit that reference to the object they're inside. Does that make sense? So in C#, I can put a login button listener class in like this, but I won't be able to access main login button in C#. But I can do that. I can do that in Java. Cool? All right, so I create this class. You'll notice it's private. Private means that nobody else can construct it. Only people who can construct it is main activity. Okay? So nobody else even knows that it exists. It's completely hidden. They don't know anything that's going with the OnClick, just like previously we had that OnClick method exposed. Here it's not. Okay, so what changes is really not that much. If you look at the top, the activity doesn't implement the interface anymore. What's implementing the interface is this class instead, right? So this nested class is implementing the OnClick Listener, not the activity. Okay? When we register the listener, rather than passing this, we say new login button listener. So we create a new instance of this class and pass it. So there's an indirection, right? So the button, when the event fires, it calls this listener object, and that in turn may call back in access to the activity. Cool. So there's another kind of layer of indirection there. Questions? Pretty simple, right? Pretty simple as a transition. But this is pretty much always preferable. There are very, very few cases where you want to do the first approach over this approach. Okay? This approach is hands down, generally speaking, the better approach. One caveat, one warning that I might throw out there. The first approach here, actually, of the approaches that we're going to talk about, uses the least amount of memory. The reason being is it doesn't have to create a separate listener object. Okay, so there are some cases where we care about memory usage, and namely that comes when we're dealing with something called a recycler view. Then we'll need to come back and have this discussion again. But large in part, it usually doesn't matter a whole ton. Here, we have a separate object being created, namely this login button listener, but it doesn't really matter because it's only ever created once. It's only ever created when this OnCreate method gets called. and it's only used in that one place, right? So it's not really a big deal, right? So it's constructed and used just once. We never can create another copy of it, right? If we're going to create a copy maybe every frame, then it would be an issue. Cool. So here this approach is perfectly okay. All right, let's look at the next approach. So the next approach, what I do is I use something called an anonymous class. Okay. Previously, I had a named nested class. This class is now anonymous. Okay. So I removed the class that I had down here and effectively moved it up into the call to set OnClick Listener. Right. So rather than separately declaring class, I'm just declaring it when I need it. Now, as far as compilation is concerned, this still generates a .class file. The previous one would generate a class file that looked like, grab a notepad. So in the previous case, the name of the class would have been, the nested class would have been like main activity, and I believe it's $, login, button, listener, .class. So if you're looking at the files that are built, that still generates a class file, a separate class file. Okay. This one, on the other hand, because it's not named, generates a class file like this, $1. So anytime you have classes like this, regardless of how you do it, you're going to get a separate class file. Okay. Nested ones have a name. These ones do not have a name, so they just get assigned a number. Cool. And then the ordering is generally where they appear on the code. So from top to bottom, the first anonymous class will be 1, and 2, and 3. It's generally something we don't want to rely on. It's not very stable. But that's kind of how it works internally. It still treats it and generates and spits it out as if they were kind of separate, almost separate Java files. Okay? All right, so here I say new view.onClick Listener. Now this is weird, right? Because I'm saying construct a new thing. Okay? I can't actually construct this thing. This is not actually legal. I can't say new view.onClick Listener because that's an interface. It's abstract. You can't construct something that's abstract. So if I were to stop there, this would be invalid syntax. If I were to stop right at the end of those parentheses, it would say, oh, you can't do that. But what I do is add this part in afterward. That says, okay, yes, I know I'm building something that's abstract. Let me fix that for you. So here's the implementation. So this gets us from something that's abstract to something that's actually concrete. So right here in the middle of constructing this object, I'm defining the implementation for it. So everybody see that? I'm defining the implementation for it. And so here is the implementation for what happens when OnClick gets called. Here's the implementation of the OnClick. Cool. So this is really nice and compact, right? It's really nice and condensed into not a lot of overhead, right? When I start to implement an event this way, I can just put all the code here. I don't have to go up to the top of the activities and change things. I don't have to go down to the bottom and define another class. I just define it where I need it. Is everybody clear with that? So it reads really well from top to bottom. That's one of the big benefits of this, is it really makes it a lot easier to read the code from the top of the file down to the bottom and have a good idea of what's going on. So this is generally preferable for a lot of Java developers will prefer to use these anonymous classes. Okay, there are two caveats and two places where I might suggest you do something a little bit different. Okay, because there's two things where this doesn't work well. One is if you need to use this listener in more than one place. This listener, I'm only ever using this one place, it's fine. I'm not going to ever repeat it. But if I needed to reuse this, I would go back to the previous approach and go ahead and define a class and give it a name, if I ever wanted to use it. In fact, if I want to use it just 2 times, I would do the first approach. This is only strictly if you're only going to use it once, which turns out to be often enough that it's an approach, that it's a choice, right? But there are plenty of cases where, oh, I need this 2 or more times, just make a nested class. Just give it a name. The other side of things is this is putting a lot of code into this one function. It can get pretty tall, right? Especially when I may be hooking up an OnCreate. I might be hooking up 5 different listeners, right? This can make my OnCreate method very, very tall. And so it only is really an advisable thing to do if it's short, right? If it's short, this is okay, right? If the lines of code between in the OnClick method are not very long, then this is a fine approach. But once you start putting more code there, go back to the previous approach and make a class, because it reads better. Everybody cool with that? That kind of makes sense? So if it gets long, go back to the other approach. If you find that you're going to reuse it, go back to the previous approach. But a lot of times you find it's short. I'm only using it once, so this works. Cool. And actually for the longest time, that was the end of the story. Up until just a few years ago, that was the end of the story for Android. Okay. Things actually did change around Android, around Java 8. Java 8, finally we got something called Lambda functions, which are great and amazing. They're kind of like what you're familiar with in some ways. They're similar to the Lambda functions that we use with Node and Lambda functions as they exist in C#, with some caveats, because Java took a completely different approach to how they implement Lambda functions than other technologies did. Another caveat, they're only available if you have Java 8, which means that older Android devices do not support the next approach that I'm going to show you. This only works on newer devices. The good news is that those devices that don't support this are basically off the market enough that we can pretend that they don't exist. Okay? So I'm going to pretend that all of the devices on the market at this point can do this 4th approach. Cool? And because we're going to set it up, I think it's around API 21 is the crossover, if I remember right, where you need to have at minimum of if it's before API 21, I don't think you get Java 8. So, next approach. Basically what we do, introduce Lambda functions, and it's a way to abbreviate this part, okay? So it's a way to abbreviate this construction of an interface, okay? Because there's a lot of noise here, right? Let's look at all the noise that's going on. We say new, construct an object of this interface, public, void, OnClick, here's the parameters and the data types. There's 2 extra sets of curly braces, one here, one here. So we're always getting 2 additional layers of indentation anytime you do this, right? There's a lot of extra noise, okay? So Lambda functions work in kind of a weird way, okay? In the Java world, there is no such thing as really a function or a delegate in the way that C# defines it. Like C# has this idea of interfaces and delegates in the way you write, and a lambda is a shorthand for delegate. Okay. In Java, instead, a lambda is shorthand for an interface. A lambda is shorthand for implementing an interface. And specifically, it works when that interface only has one method. If that interface has exactly one method, you can use a lambda function instead. If it's got more than one function, lambdas don't work. Which is one of the reasons why most of the listeners, and this has kind of been the trend even before lambdas, that the recommendation for interfaces in general is that interfaces largely should only ever have one method. Most interfaces should only have one method because that makes them good, that makes them good candidates, because of other things, but it also makes them good candidates for lambdas. Okay? So anytime you see an interface that has one method, immediately think, hey, I can use a lambda for that, and you should. Okay. So let's look at the approach. Okay. The only thing that changes here and here. The beginning and end. So right there. It starts with this input. So we have a function basically, conceptually, that takes a view. There's an arrow here. Notice the arrow though. It's kind of weird arrow. So it's a dash and a greater than. Do you remember what the arrow is in JavaScript? Equal sign greater than. That causes me no end of headaches to try and remember which sign to use. So anyway, that's the sign they use. Dash and then greater than. So this defines that we have a lambda function, and then over the right you see curly braces. Curly braces define two different bodies of the function. So the inputs and the body of the function. Okay. That gets rid of all the extra noise that we have on the previous language. Cool? It's much easier to read. And it turns out that all of those additional details didn't really matter in the first place anyway. Because, hey, set OnClick Listener. Oh, okay. So this has got to be an OnClick Listener. All the details are still there. This is a view. Oh, okay, I kind of knew that. And if I didn't know that, you can still put data types in here. You can still say view if you really want to have the data types there. But oftentimes with lambdas, you find out even the data type there is noise. Okay? Cool. Does that make sense? It's a lot easier, isn't it? I hope, than the approaches before. But what's going on behind the scenes is what we talked about before, right? This is not really all that different from the nested class approach that we took. It's kind of the same thing. It's just a shorthand for writing all of that out, right? So rather than, hey, every time I need a little function to do something, having to write it out this way and then invoke a new one, I just do all of that in one step. Construct it, define it, create it, declare it, call it. Good. Make sense? So this is largely how we're going to set up most of our listeners, is using these lambda functions. As I mentioned, these have all the caveats of anonymous classes because it really is just a shorthand for an anonymous class. So if this does get long or you find yourself reusing it, you might consider going back to a named class in either of those cases. And remember, they can only work as long as there's one method. So there are some listeners that have more than one method on them. Those ones we still have to write as anonymous classes or nested classes. We can't write those as lambdas. Cool. So this only works for handling some events. Next up, there is one other approach that you can use that's available in modern Android development. So in modern Android development, we can actually use XML instead of Java to set this up. And kind of like some of these other approaches, this doesn't work for everything. So this only works for OnClick, and it works for, I think, a handful of others. But for most events, this doesn't work. For most events, this is not an option. which is why I mentioned all the others. Okay, so for most events, this isn't an option. We use the OnClick event often enough to explain why it's there, but the Android team hasn't really gone back and said, oh, well, other things that you might want are available this way. So the way we set this up is we go to the layout file first, and we add, we're going to look at the code side of that, we add an Android OnClick property, and you point it to the name of a function, the name of a method. So we say, hey, when the user clicks on this button, call the OnClick login function. Okay, and then we define that function in the activity like so. It has to be public void, has to have the same name as in the XML, and it has to take a view. So this fifth approach is also an option. Okay. I wish that this process was a little bit easier. But as it stands, is kind of the history of Java, is we started with one approach and then got another approach and another approach and another approach, all to do kind of the same thing. Cool? So I wanted to throw this together and make sure you have it all kind of in one place, because this is definitely something I would advise you to read through again, and you're probably going to need to refer to it back to later, because it probably won't all stick today. But this is these are some of the options and some of the things you can do in Java. We use nested classes for a lot of things, so nested classes will come up again. I can guarantee you that. And some of these methods of declaring and working with events are going to come up again. Okay. So now that we've talked about the why and the how and some of the options that we have, let's go ahead and do two things. Let's take a short break, and then I'm going to come back into Android Studio, and we'll start to apply this and choose one of these methods and play around with it. Cool? So go ahead and take a 10-minute break. We'll come back at 1:45.